Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how you can use a system of equations to work backwards to find how much of a particular reactant you need to start with in order to figure out, in order to get a certain amount of product when you have certain percent yields that are involved. So let's get into this. So this is our problem. It says, suppose the following two reactions have yields of 82% and 65%. So here we have the two reactions. So this one has 82% yield and this one has a 65% yield. So then they want to know, well, how many grams of your methane, CH4, are needed in order to guarantee that you're going to get 112 grams of your CH2Cl2. And you assume you have enough Cl2. So you have excess Cl2 to keep the reaction going. So we don't need to worry about Cl2 running out. So how much CH4? So here we have our CH4. So we want to know how much of that do we need to guarantee that we're going to get 112 grams of this substance right here. So let me get another color. Do I have another color? I don't have another color, so I will circle this one. So here, so we want 112 grams of this. So how much of this do we need to start with? So we need to work backwards. So we assume that we have this. So we need to work backwards to see, well, how much of this do we need to start with in order to get that? Keeping in mind that we have 82% yield and 65% yield. So how do you do this? So you're going to do it the same way that you normally do it. You're going to use your roadmap. So again, you have mass of A, and you're going to convert that to moles of A using the molar mass of A. And then you're going to go from moles of A to moles of B. And give myself enough room here. So let me get that out of the way. And I'm going to do that by getting the mole ratio of A to B. And then I want to convert that to mass of B in grams using the molar mass of B. And so again, our goal is 112 grams of that. So how much of this do we need? So let's just start with the 112 grams and convert all the way back to CH4, to our methane. So they're giving us mass. So I'm going to start over here, give myself some room. So we're going to start with 112 grams of the CH2Cl2 because that's what we want to get. And so we want to know how much of this. So we need to work backwards this way. So in order to work backwards, I want to convert this amount of CH2Cl2 into the CH3Cl here, because I can then go from here to here in this equation to convert here. So I want to convert this to CH3Cl first, and then I can use the amount of CH3Cl that I have to convert to CH4. Okay, but I need to keep in mind that I have 65% yield here. So what does that mean? That means that this 112 grams is only 65% of what I should have theoretically gotten from this. So I lost some of my product. So I need to get that product back. So I'm going to have to use the percent yield in order to get some of that product back. So what does this mean? It means that for every 100 grams of my CH2Cl2 that I should have theoretically gotten. I only got, so this is theory, and I only got 65 grams of that actual. So what I actually got was 112 grams, but what I should have theoretically got was more. So I'm going to use this relationship to go from 65 back to 100%. So this is my actual. I'm going to call this actual. So my actual grams, this is actual grams. So 65 grams of CH2Cl2 actual, but what I should have gotten was 100%. So I'm going to put 100 grams up here. So that's CH2Cl2 theory. That's what I should have gotten. So I'm going to use that to go back to what I should have gotten. So now I've gone from actual to theoretical. So that was my theoretical amount that I should have gotten. So now I can convert that grams into moles. So using the molar mass of this substance. So you calculate the molar mass using your periodic table. And so we find that to be 84.927. So 84.927 grams of my CH2Cl2. I'm going to put T for theory, and then 1 mole of my CH2Cl2. I'm going to put T for theory. So I'm going to cancel out my grams. So now I have moles of my CH2Cl2 theoretical. So now I'm here. So notice here that I have a 1-to-1. So this is, I now have the amount that I should have gotten. Uh, this is the amount that I started with. So whatever this number of moles is, that's the number of moles that I started with in order to get the 112 grams that I actually got. So in order to get this 112 grams, I needed whatever amount this is going to be. But I'm not done yet. Now that I have this amount, this CH3Cl actually came from this reaction here. So this came from here. Okay, so the product of this is the reactant here. But notice that this product came from a reaction that is only 82% yield. So the amount that I have here is only 82% of what I should have gotten here. So I'm going to have to use this percentage as a conversion factor. So what does that mean? It means that out of 100 grams, or moles in this case, so we can use moles, out of 100 moles of my CH3Cl, I only got 82 moles. So 82 moles of CH3Cl. So this is again theoretical. That's what I should have gotten. This is what I actually got. So now this becomes the actual amount of CH2Cl. So we're going to change that to A. So what I actually got from this here is what I started here is what I actually got here. But what I should have gotten is not the theoretical. What I should have gotten is theoretical, but I didn't get that. So I'm now going to use that as a conversion factor. So this is now the actual. So 82 moles actual goes on the bottom. So 82 moles of CH Oops, that should be CH2. Oops, I forgot a step. I jumped too far ahead. So here, I'll make this theoretical again. I got jumped ahead, so theoretical. So I need to go from this to this. So that's going to be a 1-to-1 relationship. So that's, I forgot that step. So I'm going to use the mole ratio to go from CH2Cl2 to CH3Cl. So I'm going to put 1 mole of CH2Cl2 on the bottom and 1 mole of CH3Cl on the top. And so moles cancel out. Now I have moles of CH3Cl, and now we can go to here. So again, so the amount that I got here came from here, but this is the actual amount that I got, but because of the 82% yield, I should have gotten more. So we got to take this in consideration. So that's where this is going to come in. So now I'm going to add, I'm going to move it down here and continue down here. So since I have moles of CH3Cl, this is going to be the actual that I got from my reaction. So that's 82 moles. So 82 moles of CH3Cl. And then the theoretical is going to go on top. So 100 moles of CH3Cl. So this is actual, and this is what I should have gotten in theory. So I'm moving back on this equation now. So what I got here, so what I have here, I have moles of CH3Cl. That moles of CH3Cl came from here. So the amount I got here is only 82% of what I should have gotten from here. So I need to factor that in, and that's what I'm doing here. So I have 82 moles of actual and then 100 moles of theory on the top. So the actual moles cancels out here. And now I have moles of what I should have gotten from my reaction. And now I can go back this way using the mole ratio. So I have 1 mole of this for every 1 mole of this. So the mole ratio is 1-to-1. So again, 1 mole of this CH3Cl on the bottom and 1 mole of the CH4 on the top. That's going to cancel out. Again, they want grams, so we need to use the molar mass to convert to grams. So the molar mass of CH4 is 16.043. So we have 1 mole of CH4 on the bottom and 16.043 grams of CH4 on the top. So moles cancel out. And so now I have the grams of CH4 on the top. That's what I want. So I'm going to stop there. Now all I need to do is multiply by all the numbers on the top and divide by all the numbers on the bottom. You can skip the ones. So when we do that, we get 39.694. So this gives us 39. Is it 39? Did I say 39? Yes, 39.694. 39.694 grams of CH4. So the next step, the last step, is to figure out the number of significant figures. So we look here. Remember, the rule for sig figs is that your answer should have the same number of sig figs as the least number of sig figs in the numbers that you were multiplying. So here we have 112. That's 3 sig figs, and here we have 2 sig figs. So 65. That's 2 sig figs. Here we have 5 sig figs. This is an exact relationship, so that's we can ignore that. Here we have 2 sig figs, 82%. That came from 82%. 1 to 1, that's exact. Here we have 5 sig figs. So the least number of sig figs is 2. So we have 1, 2. This is 6. So that means we need to round the 9 up to a 10. So that's going to give us 40 grams of CH4. And notice I put a decimal point there. Without the decimal point, it would be only 1 sig fig. But since we need 2 sig figs, I put the point there so that 0 is significant. So this is the answer to our problem. I hope you enjoyed that. I hope you learned something. Please let me know in the comments what you think. If you have any other questions, post them. If you like my videos, please hit the like button, subscribe to my channel, and thanks for joining me. Have a great day.